Hi, folks. Today we're going to be learning about writing intercepts writing equations in slope-intercept form. And this may be a review for things you've learned from middle school, but slope-intercept form is y equals x plus b, where m is the slope and b is the y-intercept. Again, as a review, something we talked about last module, or you may have learned it in middle school. Slope is a measure of the steepness of a line. Slope is abbreviated with the letter M, and you can think of it in a few different ways. You can either think of it as being rise over run, or a change in y over the change in x, or there's a formula for calculating slope. The nice thing about this formula is that it always works. Y2 minus y1 over x2 minus x1. It always works whether you've got 2 points, whether you've got a graph that you're trying to read from. That equation always works. So let's look at some examples of using slope-intercept form. The simplest version is just I give you the slope, I give you the intercept. How do you put this together in slope-intercept form? Well, as we discussed, slope-intercept form is y equals mx plus b, and we said that m equals the slope. So if I take this slope value and plug it in where m is, then I'll be able to replace that with a number. So now I have y equals something times x, and that something is -3. And then the b value here stands for the y-intercept, and this 1/2 number is what I'm going to put in for b. And so I would put a 1/2 there. If necessary, you would simplify. And so if you had two negative signs together, a negative plus a negative is a positive, you would make simplifications like that. But this is in its simplest form already. Y equals -3x plus 1/2. So let's do another example. Here's my slope, this 0 value, and here's my y-intercept, this -2 value. So again, if I think about the form y equals mx plus b, that m represents my slope, and that b represents my y-intercept. So my y-intercept goes here where the b was, and my slope goes here where the m was, and the rest of the equation stays exactly the same. Now, this version does need to be simplified. I've got a few things here that can be made more simple. For instance, 0 times x, any number times 0, is just 0. Also, I have consecutive signs here, a positive and a negative. That's excessive, that's unnecessary. You can simplify. Adding a negative is the same as subtraction. So really what I have here is 0 minus 2, which of course equals -2. This is the simplified version of my equation. And this, as you can see, since there's no x value here, this will represent a horizontal line. So this is the most simple, straightforward example. Let's look at more complicated examples. Here we're given graphs and asked to come up with slope-intercept form. So remember, slope-intercept form is y equals mx plus b. And so the first step is to find slope. We're not told slope, so we need to calculate it. If you have a straightforward graph that's easy to read, one of the easiest ways to determine the slope is just to kind of decide what point number 1 is, decide what point number 2 is, and then make a straight up and down and straight left and right path to get there. So if I want to get from point number 1 to point number 2, first I have to go straight up. And how many units is that? That's 1, 2, 3, 4, 5, 6 units straight up. And then I go 4 units to the side, 1, 2, 3, 4. Now, we said that the slope, the m value, is the rise over the run. So my rise measurement here was 6, and my run measurement here was 4. And so 6/4 is not a reduced fraction. Putting that in lowest terms would be 3/2. And now I have my slope for this graph. Now, the y-intercept. The y-intercept is where the graph crosses the x-axis, which is right here at this point that I'm circling in green. When x equals 0, that is the y-intercept. The y-intercept. So I know that my y-intercept, my b value, is -3. Now, this is as easy of a problem as the first examples were. I know my m value, I know my b value. It's just a question of plugging it in to the slope-intercept formula. So y equals something x plus b, and my m was this purple 3/2 value, and my b was this -3 value. Is this simplified? Not quite. I have two consecutive signs here that can be combined for a final equation, which is y equals 3/2 x minus 3. Let's look at another example. For this graph here, if I decide what my point number 1 is, and decide what my point number 2 is so that I can make a plan. What you want to make sure is you're always moving from point 1 to point 2. It doesn't matter which point you say is which, but you need to be consistent about which point you're moving from and which point you're moving to. So here I go down 1, 2, 3, 4. Oh, only 3 units. I go down 1, 2, 3 units. And then I go right 1, 2, 3, 4 units. So down 3, right 4. So to calculate my slope, remember slope is rise over run. My rise isn't just 3, it's -3 because I didn't rise, I went down, and that's a negative y value. But I did move to the right, and moving to the right is a positive value, so I moved to the right 4. This slope is in lowest terms, so ready to move on to find the y-intercept. Remember, the y-intercept is where the graph crosses the y-axis. It's where x equals 0 on the function. And so here I can see that my y-intercept is +2. I'm now ready to plug these values into my y equals mx plus b formula. And my -3/4 goes here in front of the x. And then my b value is 2. So my final equation is y equals -3/4 x plus 2. I used the graphs to calculate the slope here. Um, Sometimes graphs are not easy to read. Sometimes, um, for instance, I was able to just count by one. Each box on both of these graphs represents 1 unit. So I was just count 1, 2, 3, 4, 5, 6 on here on graph A. 4. It's true on a graph. Sometimes graphs use really large numbers, and so it's annoying to count. And sometimes graphs skip count. Each tick mark means more than one. So you sometimes have to be careful when using graphs. An alternative is to use the points themselves, 0, -3, and 4, +3, to calculate the slope. And that's what we're going to do in our next example, where we're going to use points to write linear equations. So here I don't have a graph. I don't have an easy way to count what the rise is and what the run is. So instead this time, to calculate the slope, we're going to use the slope formula, which is y2 minus y1 over x2 minus x1. So just like on the graph, I do need to decide, hey, what's my point 1 going to be? So I'll call this point number 1. And what's my point 2 going to be? It doesn't matter which point you call point 1 or point 2, but it does matter that you are consistent. So if I decide on the top here to do -1 minus 5, I have called this value my y value for point 2, and I've called this value my y value for point 1. So now I need to be consistent in the denominator. I need to make sure that I'm still calling this point 2. So this is the x value for point 2 and the x value for point 1. Now, please notice this is a common mistake that students make. There's a negative sign here in the formula, and there's a negative sign here next to the x coordinate for point number 1. So both of those negative signs need to appear in my calculation. Otherwise, I'm going to get an incorrect slope. -1 minus 5 is -6, and 0 minus -3 is +3. So my slope here is -2. Now, this chapter in our textbook is kind of artificial here with this first section. Since we're doing things in slope-intercept form, they are always going to give us the y-intercept. Life is rarely that convenient. We rarely get given the y-intercept just automatically. We're going to learn in the next topic how to do these calculations even when we're not given the y-intercept. But for this introductory section, we're given the y-intercept. How do I know this is the y-intercept? Because the x value is 0. The x value is 0. So my y-intercept, my b value, is -1, because that's where x is 0, y is -1. I'm now ready to plug those values into my slope-intercept form of the equation, y equals mx plus b, and I'm going to use -2 as my slope and -1 as my y-intercept. I can simplify what I have going on with the signs here. Adding a -1 is the same as subtracting 1. So the final version of my equation is y equals -2x minus 1. Let's do another example. This time, just to be consistent, I'm going to call this point number 1, and I'll call this point number 2. And again, when I'm given 2 points and I'm trying to write the equation for the line, the formula for the line that contains those 2 points, I need to figure out the slope first. So once again, I'm going to do y2 minus y1 over x2 minus x1. And I'm going to do -5.8 minus -5.8. So I did this one first and then this one. And in the denominator, I'm going to do my x2, which is 8, minus x1, which is 0. Remember that subtracting a negative is like adding a positive. So up top, I have a 0, and on the bottom, I have 8. So my slope for this equation is 0. Once again, because this is the introductory chapter or section in the textbook, they have given us the y-intercept because x is 0 in this location. So the y-intercept is -5.8. Let's plug the values we need into the slope-intercept form of the equation. I'm going to have 0 as my slope, and I'm going to have negative 5.8 as my y-intercept. And simplifying this, I see that 0 times x is just 0, and adding a negative is the same as just subtraction. So when I do that subtraction, I get y equals negative 5.8. And we're done. Now, up until this point, I've been using y as the starting symbol for all of these equations, for all of these functions. However, last chapter we learned about function notation. So it would be just as correct for me to write this as f of x equals negative 2x minus 1, or f of x equals negative 5.8. So remember that notation as we go down to this next example. Write a linear function with the values f of 0 equals 10 and f of 6 equals 34. Remember with function notation, the number in parentheses right after the function symbol represents x, represents the independent variable. And then the number after the equal sign represents y, represents the dependent variable. Same thing here. 6 is the x value, 34 is the y value. So really, the information we've been given here is that this function goes through 2 points. One of those points has the coordinates 0, 10, the x value and the y value. The other point has the coordinates 6, 34, the x value and the y value. Even though this notation is different, this is really an identical question to what the previous section was asking, where I've given you 2 points. How do you come up with the equation for the line? So let's figure out the slope first. The slope is y2 minus y1 over x2 minus x1. And let's see, I'll call this point number 1. I'll call this point number 2. So I do 34 minus 10 over 6 minus 0. That gives me 24 divided by 6, which is 4. So my slope here is 4. Do I know what the y-intercept is? Yes, I do, because this point here has 0 as the x value. Therefore, the b value, the y-intercept, is 10. Now that I have that information, I can just plug it into slope-intercept form here. And my slope is 4, and my y-intercept is 10. This equation is simplified as it is, so I have come up with the equation for this example here. Let's look at a real world example for our last problem. We can model a real life example of looking at renewable energy resources, and some information is given to us. We're told that 143.4 million megawatt hours of electricity were made in 2009, and 333 million watt hours were made in 2017. And then it says estimate the amount of electricity generated from these sources in 2021. With problems like this involving years, quite often, although there is a year 0, but more than 2,000 years ago, um, that isn't always sensible in the context of the problem to go think all the way back to year 0. For instance, if we're talking about cell phone usage, going all the way back to year 0, of course, there was no cell phone usage. Any trend we see doesn't go all the way back to year 0. It's a more recent trend based off of when we've started collecting data. In this example, we appeared to have started collecting data on this in 2009, or at least that's where the problem starts caring about the data. So what we're going to do is we're going to kind of call this year 0. just to simplify things. Otherwise, we're going to have numbers in the thousands on our x-axis. But if we call 2009 year 0, then 2017 is 8 years later than that. This would be year 8. And then when we get to 2021, that would be year 12. So we can start counting time from 2009 in the context of this problem. So we're going to say, we're going to make 2009 0 years, and we'll just say that the x-axis is the number of years after 2009. That'll help simplify our calculations, but it also makes more sense in the context of the problem. If we didn't start collecting these data till 2009, then there's no sense in going further back in time. So, based off of this information, I now have points on the graph. If I start at year 0, the energy generated was 143.4 million. And then when I got to 2017, which was year 8, I had a value of 333 million. So this word problem has really given me 2 points on a line. I know it's a line because the problem tells me that it's increasing at an approximately constant rate. So I can use these 2 points to determine the equation for the line the exact same way we did with the problems earlier. So we can calculate the slope by doing the y2 minus y1 over x2 minus x1. So I'm going to have 333 minus 143.4 divided by 8 minus 0. That gives us 189.6 over 8, which works out to be 23.7 as our slope. Now, in a real world problem, slope has units. The y value, the rise, has units of million megawatt hours, which I'm just going to write MMH for short. And then the run has units of years. So what we have here when we calculate the slope, rise over run, is million megawatt hours per year. So slope does have units, and that's an important thing to be aware of. Let's figure out the b value. Do we know where the y-intercept is? Yes, we do, because we were given, one of our points was given with an x value of 0. So we know that the y-intercept is 143.4. We're now ready to plug the values that we calculated into our slope-intercept form. And the slope was 23.7, and the b value was 143. I meant to write that in green. 143.4. Now, we have a complete equation here, but we haven't actually answered the question. This says, estimate the amount of electricity generated from these sources in 2021, in year 12. How do I use that information to to answer the question? Well, year, remember, is our x value. I can use this 12, this number of years after 2009, as my input value, as my x value, and calculate my y value. So what I'm doing here is I'm taking y equals 23.7 and multiplying it by 12, and then adding 143.4. When I do that calculation out, I get 427.8 as my answer. This is million megawatt hours. 427.8 million megawatt hours in year 12, which is the year 2021. I hope this helps.